Okay, let's unpack this. Today, we are embarking on a deep dive into something, well, incredibly fundamental to the human experience, wouldn't you say?
Absolutely. It's part of how our brains just grapple with the sheer complexity of the world around us.
Yeah, and it feels completely natural, maybe even, essential for survival. I'm talking about the drive to find patterns.
It's deeply ingrained, isn't it? Our brains are just masters at connecting dots. I mean,
hmm
think about how we see shapes in clouds drifting overhead.
Oh, totally. Or how ancient cultures looked up at the stars and, well, wove them into constellations, right?
Exactly. Seeing narratives, figures where there were really just scattered points of light, this ability to find structure, to see connections.
Yeah.
It's the bedrock of learning, prediction, making sense of everything.
Absolutely. It's how we anticipate outcomes, like knowing that a certain kind of cloudy sky often means rain, or recognizing a familiar face in a busy street.
Sure.
It's even behind some incredible breakthroughs, like Ree Kroc noticing that one McDonald's location was ordering this unusually high number of multimixers back in the 50s.
Right, I remember reading about that. He saw a pattern, didn't he?
He did, a pattern in the sales data that just shouted, something different is happening here, an operation unlike any he'd seen.
And that pattern led him to investigate and, well,
The rest is history, pretty much. It sparked the whole global expansion of McDonald's. He's spotted a real, meaningful pattern where others might have just seen, I don't know, a fluke.
that Kroc example is perfect because
Yeah.
it really highlights the adaptive, the beneficial side of our pattern-seeking brain. But, as you hinted, this powerful engine for finding connections. It can also go a bit haywire.
Haywire how?
Well, it can perceive patterns that aren't actually there, or it assigns meaning where none objectively exists.
And that's exactly where our topic for today, this fascinating concept called apophenia, comes into play.
Apophenia, yeah.
Yeah.
The core idea, and this comes directly from the sources we're looking at today, it's defined as the spontaneous perception, or finding, of meaningful connections
Okay.
or patterns.
In stuff that's totally random or unrelated.
Precisely. In random or unrelated phenomena. It's like the brain's really sophisticated pattern matching system is just working overtime, identifying connections that aren't truly warranted by the data or, the stimuli it's receiving.
It's like the brain shouts, aha, I see a connection here.
Oh.
But if you look objectively, there's no actual relationship between the things it's linking up.
Exactly. And importantly, that connection it perceives isn't just some random observation. It feels meaningful to the person experiencing it. That's key.
The meaningful aspect.
Yes, that's crucial. It's not just noticing two things happening around the same time. It's the assignment of significance, a sense of some underlying relationship, maybe even causality, that just isn't supported by external evidence.
Mm-hmm.
And the sources discuss this subtle nuance here. Is it about seeing patterns that literally aren't present at all? Or is it seeing patterns that might exist statistically, but are actually completely meaningless in any practical or predictive sense?
Okay, so there's a bit of debate there.
A slight one, but the consensus kind of leans towards the perception of falsely detected meaningful connections, or patterns where objectively none exist or are meaningful in reality.
So it's definitely distinct from just general pattern recognition, which, as we said, is vital for us.
Oh, completely distinct in its outcome, yeah. Even though it seems to arise from the same underlying cognitive machinery,
Right.
general pattern recognition is adaptive. It lets us learn from experience, make predictions, understand sequences. It's how we know, certain cloud formations mean a storm's coming, or how we learn the structure of language.
But apophenia, that's different.
Apophenia, in contrast, is like a misfiring or an error in this system. It's often characterized as a type I cognitive error.
A false positive.
Exactly, a false positive. The brain detects something, a pattern, but it's a pattern that leads to an incorrect conclusion about reality because the perceived connection just isn't valid.
Okay, a false positive in pattern detection. Got it. The sources also bring up several terms that seem closely related to apophenia, sometimes even used interchangeably for specific types.
Yes, there are a few important ones.
Mm-hmm.
Probably the most widely recognized, especially in popular culture, is pareidolia.
Ah, pareidolia. That's the one everyone knows, right? Seeing faces and things, like ghosts or clouds.
Exactly. Pareidolia is a specific type of apophenia. It's focused purely on illusory visual perception. So the tendency to perceive familiar patterns, most commonly faces, yeah, but also animals or other shapes in random visual stuff.
Like seeing a face in the grain of wood, or the patterns on a piece of toast, or the classic cloud shapes.
You got it. It's visual pattern finding gone slightly speculative, let's say.
Speculative. I like that.
Yep.
Okay, what else?
Right. Then there's patternicity.
Mm-hmm.
This term was coined by Michael Shermer,
Sure, yeah.
and it describes the broader tendency to find meaningful patterns in basically meaningless noise. It's very close to the core definition of apophenia, but maybe puts a bit more emphasis on the chaotic, the noisy nature of the data where the pattern is supposedly found.
Okay, so patternicity is like a general tendency to find patterns in randomness, while apophenia is more the specific act of perceiving those meaningful but false connections. Makes sense. What about agenticity? That sounds like it relates to seeing agents or intentions.
It does, precisely. Agenticity is the tendency to infer intentional agents, minds, spirits, forces, conscious entities behind patterns or events where there is only randomness or just impersonal physical processes. This concept is really relevant when we think about why people might attribute, say, a natural disaster to divine will, or see a series of coincidences as the work of some specific person or group orchestrating events behind the scenes.
So seeing design or intention where there's just chance.
Exactly. It's a powerful concept, isn't it? Linking pattern finding directly to beliefs about unseen forces or intentions.
Yeah, it really is. And finally, clustering illusion.
Clustering illusion is another related cognitive bias. It's specifically about perceiving patterns in how data is distributed. So it's the tendency to see clusters or streaks in random data as being significant patterns.
When actually those clusters are statistically likely just due to chance.
Precisely. If you just scatter random points on a map, they won't be perfectly even, right? There will naturally be areas with more points clustered together. The clustering illusion is seeing one of these random clumps and assuming it must be due to some underlying cause, some non-random process.
Instead of just, well, the nature of randomness itself, like seeing a hot streak in gambling, which we mentioned earlier.
Exactly like that. Or a slightly more serious example, perceiving cancer clusters in certain geographic areas without properly controlling for all the confounding factors or really understanding random distribution. It's interpreting chance variations as meaningful structure.
It's fascinating how many distinct but related ways our brains are kind of biased towards finding patterns, even where they don't exist meaningfully or predictably.
It truly underscores how fundamental this drive is. Our brains are pattern-making machines, and sometimes, well, they make patterns that aren't quite real.
Okay, let's dive into some more concrete examples then. Apophenia in action. Both the everyday stuff and maybe some more notable instances. You started with pareidolia, the visual one.
Right. And pareidolia is just everywhere once you start looking for it. The face on Mars is such a classic, well-documented example from the sources.
Oh yeah, the Cydonia region photo from Viking 1.
That's the one. Back in 1976, NASA's Viking 1 took this photo of a mesa. And just due to the specific lighting, the shadows, the camera angle, it looked remarkably like a human face.
And people went wild with it, right?
Oh, absolutely.
Yeah.
That single image sparked decades of speculation about intelligent life on Mars, hidden artificial structures, government cover-ups, you name it.
Until they got better pictures later on.
Yeah. Exactly. Later, higher resolution images revealed it was just a natural rock formation, a trick of light and shadow. But it shows the power of this bias, how convincing it can be.
It really does.
And it's not just famous space rocks, though. Seeing animals or faces or whatever in clouds, most of us have done that since we were kids.
Yeah.
That's pareidolia.
Sure.
Mistaking a coat hanging on a chair in a dark room for a person for a split second.
Yeah, it happens all the time.
Or seeing faces in electrical outlets. Or,
Yeah.
well, finding the Virgin Mary in a grilled cheese sandwich.
Yeah.
These are all common, mostly harmless examples of our visual system imposing familiar patterns onto ambiguous visual input.
And you mentioned it's not just visual, there are auditory examples too.
Yes. Auditory apophenia is also pretty common.
Yes.
Hearing your name called out in a really crowded, noisy place when actually no one called you.
Uh-huh. Your brain's kind of primed for your name.
Exactly. Our brains are tuned to detect our names. And in all that noise, sometimes the random sound just hits a pattern close enough to trigger that recognition. Another classic example, often discussed in the sources, is hearing words or hidden messages in music, especially in distorted audio or, the whole backmasking thing.
Ah, playing records backward to hear secret messages.
Right. People have claimed to hear all sorts of things, hidden satanic messages or other phrases, when music is played backward, even when the musicians swear they never intended anything like that. The brain is just actively trying to find structure and meaning in the sound waves.
And sometimes it constructs words or phrases from what's essentially just random noise.
Precisely. The brain is anticipating patterns, and if the input is ambiguous, it's sort of fills in the blanks with familiar structures like faces or words.
That makes a lot of sense.
Huh.
Okay, now let's circle back to the gambler's fallacy. You said that's a prime example of apophenia in the context of randomness and probability.
It really is.
So how does that false belief that past random events influence future ones connect to seeing patterns where they don't exist?
Okay, let's take a simple coin flip. A truly random event, right? 50-50 chance for heads or tails on each independent flip.
Right. Independent is the key word.
Absolutely. The gambler's fallacy happens when someone sees a sequence, let's say 5 tails in a row. They perceive a pattern, there's a streak, or maybe an imbalance, and then they assign meaning to this sequence. They start believing that because tails has come up so many times, heads is now somehow due, that the probability of heads on the next flip is actually higher than 50%.
But in reality, each coin flip is completely independent. The coin doesn't remember the previous flips. The probability stays 50-50 no matter what happened before.
Precisely. The person is seeing a meaningful pattern, like tails is on a streak, or the outcomes need to balance out now, in a sequence of completely random, unrelated events. They're applying a rule or a structure where none exists, perceiving a connection between past and future, flux that just isn't objectively real.
And that misapplication of pattern recognition to randomness, that's a hallmark of apophenia.
Absolutely.
And this isn't just limited to casinos, is it? The sources mention that even researchers analyzing really large data sets can fall prey to this, finding patterns in random information that might lead to inaccurate conclusions.
This is a really, really crucial point, especially now in the age of big data, when you have these massive data sets with hundreds, maybe thousands of variables.
Yeah.
It becomes statistically pretty likely that you will find correlations between some variables just purely by chance, even if there's absolutely no real relationship between them and the underlying reality.
Like finding a strong correlation between, I don't know, the number of storks in a region and the birth rate 9 months later. Isn't that a classic example?
Exactly. That's a perfect, well-known example of what we call a spurious correlation. Your pattern detection system finds the correlation in the numbers as one goes up, the other goes up, and it naturally tries to assign meaning or causality. Aha! Storks bring babies.
Right, even though it's obviously not true. Of course not. Both are likely correlated with other factors, maybe something simple like population density or general time trends. Without really rigorous statistical methods, careful experimental design, and crucially, the willingness to test and falsify your hypotheses, it's incredibly easy to find these spurious patterns in data and become convinced they're real.
So the brain's natural tendency to seek patterns needs to be rigorously checked by the scientific method, essentially, to make sure the patterns we identify are actually meaningful and not just noise or chance associations.
Absolutely. Science is, in many ways, a formalized process designed specifically to minimize the impact of cognitive biases, like apophenia, and relatedly confirmation bias, when we're trying to identify real patterns and relationships in the world.
This brings us beautifully to a classic study discussed in the sources that gives a very simple but pretty profound demonstration of how easily these unfounded associations can form. Skinner's pigeon experiment. Ah, yes, Skinner's pigeons. This experiment by B.F. Skinner is a really striking illustration of what he termed superstitious behavior, which is basically a form of apophenia.
So what did he do?
Skinner placed hungry pigeons in a Skinner box, and he set it up to deliver food pellets automatically at fixed intervals, say, every 15 seconds. Crucially, this was regardless of what the pigeon was actually doing at the time.
So the food delivery was completely random relative to the pigeon's behavior, no connection at all.
Precisely. Now, a hungry pigeon in a box isn't just going to sit still, right? It's moving around, pecking corners, churning, maybe flapping its wings.
Sure.
So by pure chance, a food pellet would arrive at some point. The pigeon, being a learning organism driven to find patterns that predict rewards, would then think about what it was doing just before the food appeared.
And then it would repeat that action, hoping the food would come again.
Exactly. The pigeon's brain drew a connection. I was doing X and food appeared. Therefore, doing X makes food appear, even though the food delivery was totally independent of its actions. But the random reinforcement would happen often enough because the pigeon kept repeating X to convince the pigeon that there was a causal link.
So it developed a ritual.
Over time, yeah. Each pigeon developed its own unique, kind of bizarre ritual or superstition. One might turn circles constantly, another might bob its head up and down repeatedly, another might make these weird pendulum swings with its head.
Why?
because those specific actions had been accidentally paired with food delivery just enough times to create a false, perceived pattern of causality in the pigeon's mind.
That's a perfect, simple model for how superstitions form in humans, too, isn't it? We do something good happens by chance, and we might connect the two events even if there's no actual link, like wearing a lucky shirt.
It absolutely is.
Yeah.
It demonstrates this fundamental tendency to find patterns, especially causal ones, even in purely random events, and how accidental reinforcement can really solidify those unfounded beliefs.
So, comparing the pigeon experiment and the ray croc example really highlights the crucial difference, doesn't it?
It does.
Apophenia is finding patterns where none exist meaningfully, like the pigeon's ritual or the gambler's fallacy, while effective pattern detection is finding patterns based on real significant signals in the data, like Ray Kroc's multi-mixer order.
Absolutely. It's the same underlying cognitive engine, fundamentally. But its output can be either a genuine insight into reality or, well, a distortion of it.
This naturally leads us to think about the whole spectrum of pattern seeing. As you said, it's not an all or nothing thing. Our brains are fundamentally wired this way.
They absolutely are. Pattern recognition isn't just some quirk. It's a foundational cognitive process. It's essential for human survival and progress. Our ability to identify patterns lets us predict our environment, understand cause and effect, learn skills, communicate through language.
Yeah, the basics of functioning.
Pretty much. And the sources highlight that this ability offered a huge evolutionary advantage. Being able to spot the pattern of a predator's camouflaged outline in the grass, or recognize the visual pattern of edible plants versus poisonous ones, or understand the sequential patterns needed to make a tool.
Those better at pattern recognition were more likely to survive and pass on their genes.
Exactly. Those individuals had a better chance. It's fascinating to think that this deep-seated drive is rooted in ancient survival needs.
And our evolution, particularly the massive expansion of the neocortex, that outermost layer of our brain, it's intrinsically linked to this advanced pattern processing ability, right?
Absolutely. The neocortex is constantly adapting, rewiring itself throughout our lives to recognize, store, and use new patterns. The sources even note that in certain complex pattern detection tasks, humans still outperform sophisticated computer algorithms.
Really? That's interesting.
Yeah, we seem to have this remarkable, maybe intuitive ability to see connections that machines might miss, at least for now.
That definitely puts our squishy brains in perspective against AI.
For now, at least in some areas. But, as we discussed, this powerful system is prone to errors. And apophenia represents a significant type of cognitive error, that false positive in pattern detection we talked about.
Right. It's when the brain confidently identifies a pattern or a connection, but that pattern doesn't actually correspond to objective reality in a meaningful way.
And this kind of false insight, it can happen to anyone. Seeing patterns that aren't objectively real doesn't automatically mean there's a problem. That's really important.
Okay.
Everyday apophenia, like seeing faces in clouds or having a mild gambler's fallacy moment, that's just part of normal human variation in cognition. However, this is where the clinical connection becomes critical.
Okay. Bringing us back to Klaus Conrad's original work in 1958 and more recent studies like that Blaine et al. Paper you mentioned.
Exactly. So how does apophenia manifest in conditions involving psychosis?
Yeah.
Well, in clinical psychology and psychiatry, apophenia is recognized as a significant transdiagnostic feature.
Transdiagnostic, meaning it cuts across different diagnoses.
Precisely. It's a symptom or characteristic that isn't confined to just one single diagnosis, but appears across various conditions, particularly those involving psychosis. It's most prominently associated with schizophrenia. That's where Conrad first described it, in relation to those sudden, unfounded insights people experience at the illness's onset.
But it's not only schizophrenia.
No, not at all. It's also seen in other conditions where reality testing is impaired. Things like schizotypal personality disorder, paranoid personality disorder, and sometimes in severe episodes of depression or bipolar disorder that include psychotic features.
So it's a core element when these other conditions involve that break from reality, the psychosis.
Exactly. And in these clinical contexts, apophenia contributes significantly to the distortion of reality experienced by the individual. It manifests primarily as false beliefs, what we call delusions, and inaccurate sensory experiences or hallucinations.
So the pattern-finding system goes wrong.
Fundamentally awry, yes. It blurs the lines between internally generated thoughts, perceptions, or associations and the actual external world.
Can you give a more concrete example of how apophenia might fuel, say, a delusion?
Certainly. Let's take a delusion of paranoia, or maybe a complex conspiracy theory, which some sources link to extreme forms of apophenia. Someone might notice seemingly unrelated events, maybe a certain color car driving past their house several times,
Okay.
or a specific news report they saw on television, maybe a comment they overheard in a shop. Their brain, driven by this tendency to find meaningful patterns, starts connecting these disparate events into an elaborate but completely unfounded narrative.
So it weaves them together.
Exactly. They perceive a pattern suggesting these events are all signals, maybe orchestrated by some external group or force that's monitoring or targeting them. They assign deep personal significance and connection to things that are, in objective reality, just random or unconnected coincidences.
So the brain isn't just seeing isolated events, it's actively weaving them into a coherent but false pattern of meaning and intent.
What? Precisely. These delusions can be seen as pathological dysregulations of imagination and pattern processing. The mind constructs this elaborate, internally consistent pattern of reality that just doesn't align with external evidence.
And hallucinations, how do they fit in?
Similarly, hallucinations like hearing voices or seeing things that aren't there can involve misinterpreting random neural activity or just sensory noise as meaningful external stimuli. The brain's pattern recognition system might be detecting patterns in its own internal signals or in low-level sensory input and incorrectly assigning them the significance of external reality. The sources also mention that dysregulated inferring of agency or intentions is seen in some conditions, which links right back to agenticity perceiving external forces or agents controlling one's thoughts or events, which is a common type of delusion.
It really highlights how the same fundamental cognitive process can lead to anything from harmless cloud gazing to, well, profoundly debilitating distortions of reality.
It really does. The continuum is vast. And the sources discuss that this clinical manifestation of apophenia might be linked to underlying physiological differences, maybe abnormalities in brain structure or function, particularly in areas critical for learning and pattern processing.
Right.
The PubMed Central source specifically discusses aberrant pattern processing as being fundamental to various major psychiatric disorders, describing it as skewing what they call superior pattern processing, SPP, and leading to a dissolution of the boundaries between imagination and external reality.
Superior pattern processing, SPP. Okay, let's spend a bit more time on that. That sounds like a key concept from the sources for understanding the brain basis here.
Yes, it seems to be. The PubMed Central source proposes that superior pattern processing, or SPP, is the foundational cognitive ability underlying many of the uniquely human higher-level functions.
Like what kind of functions?
Think of language, our sophisticated intelligence, creativity, invention, imagination, even the capacity for belief in abstract or imaginary entities like fictional characters, spirits, gods, you name it.
So the same brain power that lets us, I don't know, build rockets or compose symphonies also allows us to create and believe in complex mythologies. Is that the idea?
That's the core argument presented in that source, yeah. SPP involves taking incoming sensory data or internally generated thoughts or existing knowledge, identifying patterns within it, combining those patterns in novel ways, that's integration, storing them, and then applying them or creating new patterns, that's transfer.
And this works on real-world patterns and imagined ones.
Exactly. This process can operate on patterns perceived from the external world or patterns fabricated internally through imagination.
Okay. And which brain regions are central to this SPP and pattern processing? You mentioned some key areas.
Yes, several key areas are implicated. We've already touched on the neocortex. That's seen as the primary area for general pattern recognition across various domains. Its immense size and complexity in humans allow for the processing of incredibly intricate patterns, forming the basis for much of our higher cognition.
Right, the big wrinkly part.
Pretty much. Then there's the prefrontal cortex, PFC, particularly the areas that are hugely expanded in humans compared to other primates. The PFC is critical for all those executive functions: decision-making, planning, working memory, evaluating the relevance and meaning of information, complex social cognition.
So it's like the brain's CEO.
In a way, yeah. And the sources highlight that the PFC plays a major role in the higher-level aspects of SPP. And, crucially, it shows significant abnormalities in major psychiatric disorders. Its role in evaluating meaning is particularly relevant to apophenia. Dysfunction here could contribute to assigning unwarranted significance to perceived patterns.
So if the PFC isn't correctly filtering or evaluating patterns, it could lead to misinterpreting social cues as threatening, like in paranoia, or assigning way too much importance to minor details.
Exactly. It's involved in discerning which patterns are relevant and meaningful and which are just noise. An impaired PFC could contribute to difficulty in making that distinction, leading to false conclusions based on perceived patterns.
Okay. What else? You mentioned the hippocampus.
Right. The hippocampus is also crucial, though perhaps for a more foundational aspect of pattern processing. While we often think of it for memory formation, the hippocampus is vital for something called spatial pattern separation.
Spatial pattern separation. What's that?
It's the ability to distinguish between similar patterns, particularly spatial layouts. Think about navigating a city. You need to distinguish between very similar-looking streets or buildings to know exactly where you are. The hippocampus helps you do that.
So it helps us avoid confusing similar things by focusing on the fine details that make them different.
Yes, precisely. And while the spatial pattern separation ability is conserved across mammals, the capacity to encode these detailed patterns accurately is fundamental for the higher-level human SPP abilities like language and complex problem-solving. Those rely on processing intricate sequences and structures.
Okay.
Furthermore, the hippocampus is implicated in anxiety and depression, and impaired spatial pattern separation in the hippocampus has been linked to these conditions in the sources.
Really? How so?
Well, it's speculated that difficulty distinguishing between, say, safe and threatening contexts, or even between past ruminations and current reality, could be related to a breakdown in this pattern separation ability.
That's a fascinating connection. If you can't easily separate similar patterns in your environment or even in your own thoughts, it seems plausible that could contribute to persistent anxiety or getting stuck in those cycles of rumination.
It suggests that the brain's fundamental ability to discriminate between similar patterns has implications far beyond just, finding your way around town.
Definitely. Any other brain areas involved?
Yes. Finally, the visual cortex and the parietal temporal occipital PTO association area are also important, simply because so much of human SPP, particularly language and communication, relies heavily on processing complex visual and auditory patterns.
Like reading letters or hearing speech sounds?
Exactly. The shapes of letters, the sequences of sounds in speech, the visual cues and social interaction. These areas are where the initial sensory input gets processed into recognizable patterns, which are then integrated by higher areas like the neocortex and the PFC.
Okay, so it's a really sophisticated, interconnected network then. You've got the visual PTO areas processing the raw sensory patterns, the hippocampus fine-tuning the details and separating similar ones, the neocortex doing the general high-level recognition, and the prefrontal cortex assigning meaning, making decisions, and integrating it all into complex thought and behavior.
That's a good summary. And as the sources emphasize, dysregulation anywhere within this network can lead to aberrant SPP, where the system generates or interprets patterns incorrectly, resulting in those distortions of reality and imagination characteristic of psychiatric disorders.
Right. And you mentioned the specific links between impaired hippocampal spatial pattern separation and anxiety depression are highlighted.
Yes, as is the broader decline in pattern processing ability seen in neurodegenerative diseases like Alzheimer's.
You mentioned the clock drawing test earlier as a way this decline in PP ability is observed in Alzheimer's. Could you just elaborate on that a bit? How does that work?
Absolutely. The clock drawing test is a common cognitive screening tool, really quick and informative. Patients are asked simply to draw a clock face and then set the hands to a specific time, like 10 past 11.
Seems simple enough.
It does, but this seemingly simple task requires the integration of several distinct pattern processing abilities. First, you have to recall the visual pattern of a clock face itself, the circle, the numbers 1 through 12, their correct spatial positions relative to each other.
Okay.
Second, you need to understand and reproduce the specific spatial pattern of the hands to represent the requested time, knowing precisely where the shorthand and the longhand should point relative to those numbers.
Right, requires spatial reasoning.
Exactly.
Cool.
As Alzheimer's disease progresses, particularly affecting areas like the hippocampus and parts of the cortex crucial for spatial and visual pattern processing, the ability to correctly encode, retain, and reproduce this pattern deteriorates noticeably.
What kind of errors do you see?
All sorts. Numbers might be missing or written in the wrong order, maybe crowded into one half of the circle, which shows spatial pattern disorganization. Or the hands are just set incorrectly, or maybe only one hand is drawn. This inability to handle a relatively simple, very familiar visual and spatial pattern serves as a clear clinical demonstration of the decline in fundamental pattern processing abilities.
That makes it very concrete. It's not just some abstract cognitive decline, it's the breakdown of the brain's ability to manage specific patterns that are pretty essential for daily tasks.
It truly highlights the foundational nature of pattern processing for even seemingly simple cognitive functions we take for granted.
Okay, so given the complexity of apophenia, this whole spectrum from normal error to clinical symptom, its distributed brain basis, how do researchers actually go about studying and measuring it scientifically? The sources mention this is quite challenging.
It is indeed challenging, yeah. The Blaine-Adel paper specifically points this out. You can't just, put someone in an fMRI scanner and say, okay, show me the apophenia.
Right, it's an internal thing.
It's an internal cognitive process, yeah. You have to infer it from behavior and maybe subjective report. So researchers have developed various behavioral tasks designed to tap into this tendency. They operationalize apophenia as the rate of false positives in different domains of pattern detection.
So they create situations where the brain might see a pattern that isn't really there, and they basically count how often the person incorrectly identifies one.
Precisely. A false positive in these contexts means identifying a pattern or connection in stimuli that are objectively random or unrelated. The Blaine et al. Paper describes several types of tasks used to measure this.
Like what?
Okay, one is the Pen-Short Continuous Performance Task, STCPT. In this task, participants see a rapid sequence of visual stimuli on a screen. Most are just distractors, but occasionally a target image appears, maybe following a specific rule or pattern. A false positive here would be identifying a distractor image as a target.
So seeing the target pattern when it wasn't actually there?
Exactly. This measures vigilance, but also the tendency to perceive the target pattern even when it's absent in the stimulus.
Okay, what else?
Another is an emotion recognition task. Participants view images of faces and are asked to identify the emotion being expressed: happy, sad, angry, fearful. Crucially, some of the faces shown are deliberately neutral. A false positive in this task is labeling one of those neutral faces as actually having an emotion, like seeing anger or fear in a completely neutral expression. This measures the tendency to interpret ambiguous or neutral social stimuli as containing meaningful emotional patterns or signals that aren't objectively there.
That makes sense. If you're prone to seeing patterns, you might project an emotion onto a blank slate, so to speak.
Exactly. Then there's also a semantic retrieval task. Here, participants see pairs of words and have to decide if the words are related in meaning. Some pairs are clearly related, like doctor and nurse, but others are completely unrelated, like cloud and bicycle.
Right.
A false positive is calling an unrelated word pair related. This measures the tendency to spontaneously find or impose meaningful connections between concepts that are objectively unconnected.
Finding links where none exist.
Precisely. And finally, they mention an auditory detection task. Participants listen to audio clips. Some might contain speech sounds masked by noise, but critically, some trials contain only pure white noise. Nothing else.
And a false positive is
reporting that they heard speech during a trial that contained only that static white noise. This measures the tendency to perceive auditory patterns, specifically meaningful sounds like speech, in random ambient noise.
These tasks seem like really clever ways to probe this tendency across different sensory and cognitive domains: visual, social, semantic, auditory.
They aim to get at that underlying mechanism, the predisposition to perceive patterns or connections in random or ambiguous input in a more objective way than just asking someone about their experiences.
Right, because asking might not be reliable.
Well, the study notes that while researchers also use self-report questionnaires to assess traits related to psychosis or unusual experiences, they mentioned scales from instruments like the Achenbach Self-Report, ASR, the Multidimensional Personality Questionnaire, MPQ, the Personality Inventory for DSM-5, PID-5, and the O-Life scale.
Yeah.
Using multiple behavioral tasks like the ones we just discussed offers distinct advantages over relying solely on those questionnaires.
Why is that? Why are behavioral tasks preferred over just asking people?
Relying solely on self-report has inherent limitations. People's insight into their own cognitive biases or tendencies might be limited. They might not be consciously aware of how often they perceive false patterns.
Or they might not want to admit it.
Or their reports could be influenced by social desirability wanting to appear normal or rational. Behavioral tasks, in contrast, can potentially tap into these tendencies more directly and objectively, You're observing what the brain does under controlled conditions rather than just what the person reports experiencing.
So this research, using objective measures, it fits into a larger picture of understanding mental health, doesn't it?
Yes, absolutely. This research into apophenia and aberrant pattern processing aligns really well with modern frameworks for understanding psychopathology. Things like the hierarchical taxonomy of psychopathology, HITOP, and the National Institute of Mental Health's Research Domain Criteria, RDOC initiative.
And those frameworks focus more on underlying dimensions rather than strict categories.
Exactly. They're moving away from strictly defined diagnostic boxes like schizophrenia or depression and towards identifying core transdiagnostic dimensions or features like this tendency for aberrant pattern processing that might cut across different disorders and contribute to various symptoms.
So studying apophenia with these objective measures helps researchers understand the underlying cognitive mechanisms that might contribute to symptoms seen in a whole range of conditions, from anxiety and depression all the way to psychosis.
That's the goal, yeah.
It really sounds like apophenia is less of a singular thing and more of a fundamental cognitive process, one that can be measured and studied scientifically, linking our everyday experiences of seeing faces in clouds right through to complex psychiatric symptoms.
That's a very good way to put it. It's increasingly seen as a potentially unifying cognitive mechanism that manifests across a really wide spectrum of human experience, from totally adaptive learning to, at the other end, significant reality distortion.
Wow, that has been a truly comprehensive deep dive. We've really journeyed from the simple act of seeing shapes in clouds all the way to the complex neural networks involved in our capacity for language, imagination, and unfortunately, sometimes delusion.
We really covered a lot. We defined apophenia as that perception of meaningful patterns in randomness, making sure to distinguish it from essential adaptive pattern recognition. We explored how it manifests in those vivid examples like pareidolia, the faces everywhere, the gambler's fallacy, how even careful researchers can find spurious correlations in data if they're not careful, and that classic demonstration of superstitious behavior in Skinner's pigeons.
And we contrasted that with effective pattern detection, like the Ray Kroc story spotting the genuine anomaly that actually led to innovation. Then we delved into the spectrum, recognizing apophenia as a potential cognitive error present in pretty much everyone to some degree.
But also underscoring its critical role as a transdiagnostic feature in conditions involving psychosis, where it really fuels delusions and hallucinations, significant distortion of reality.
We connected this to broader cognitive concepts too, like biases, particularly confirmation bias, and saw how they can create this kind of feedback loop that reinforces false beliefs based on perceived patterns.
And we touched upon that intriguing link between apophenia and receptivity to what was called pseudo-profound bullshit, finding unwarranted meaning in deliberately vague or meaningless statements.
Right. Then we explored the neural underpinnings, discussing that concept of superior pattern processing, SPP, as the basis for many unique human abilities, and highlighted the key roles of the neocortex, the prefrontal cortex, the hippocampus, especially for spatial pattern separation, and its link to anxiety and depression.
And the visual and PTO areas.
Yeah.
Noting how dysregulation in this whole network contributes to disordered cognition, including that loss of pattern processing ability seen in conditions like Alzheimer's, vividly illustrated by the clock drawing test.
And finally, we looked at how researchers are tackling the challenge of scientifically measuring this elusive concept using those clever behavioral tasks designed to capture false positives in pattern detection, preferring these objective measures over just self-report to gain a clearer understanding of apophenia across the whole cognitive and clinical spectrum.
Yeah, it's quite the landscape.
What really stands out here, I think, is just how deeply ingrained this tendency is. It's a core part of what makes us capable learners and creators, but it's also what makes us vulnerable to misinterpretation and sometimes really distorted beliefs.
Yes, exactly. Understanding apophenia isn't just about pathology or studying something over there. It's about understanding a fundamental aspect of your own mind. It influences how you interpret the world around you, how you form connections between events, how you evaluate information you come across, and ultimately the beliefs you hold, whether they're about small superstitions or much larger narratives.
That's so true. In a world that's just saturated with information, where spurious correlations are so easily found and sometimes presented as meaningful patterns, and where ambiguous statements can be cleverly crafted to sound profound, being aware of your brain's powerful, almost automatic tendency to connect dots, sometimes incorrectly, that awareness is a vital tool. It's crucial for critical thinking, for navigating reality. It empowers you to pause and actually question question the patterns you think you see.
Which really raises a critical question, I think, for you, the listener, to ponder as you go about your day. Our incredible ability to find patterns has been the engine driving human progress. Everything from developing language and scientific theories to creating art and inventing technology. It's fundamental.
Absolutely.
But this very same mechanism can lead us deeply astray. It can cause us to see conspiracies where none exist, to accept misinformation simply because it fits a perceived pattern we already believe in, or to misinterpret reality in ways that can be personally or even socially harmful.
So the question becomes, how do we consciously cultivate the skills and the mindset necessary to discern valid patterns from apophenia? How do we harness our natural pattern-seeking ability for genuine discovery, understanding, and creativity, rather than falling prey to unfounded beliefs, biases, and distorted perceptions?
Yeah. How do we strike that delicate balance between having an open, curious mind that's eager to find connections and developing a healthy, critical skepticism that rigorously questions the patterns it perceives? That's the challenge, isn't it?